You ever walk past a hospital construction site and wonder what's really going on behind all those barriers? Well, I can tell you, it is so much more than just another building going up. Hospitals are, without a doubt, some of the most complex, high-stakes structures we can possibly build. They're these incredible technological marvels that have to work perfectly 24/7, even while they're literally being torn apart and rebuilt. So let's dive into this hidden world of healthcare construction.
And to really get a sense of just how high the stakes are, let me start with a question for you. Think about all the ways an infection can spread in a hospital. Now, what percentage of deaths from those infections do you think can be traced directly back to construction or renovation work?
The answer? Somewhere between 5 and 7%. Now, that might not sound like a huge number at first, but think about the millions and millions of patients in hospitals every year. It becomes a staggering figure. We're not talking about accidents with power tools here. We're talking about invisible threats that get unleashed by the construction itself.
And really, this is the perfect way to think about it. Renovating a hospital isn't like remodeling your kitchen where you can just, shut things down for a while. Critical care is ongoing, major surgeries are happening, and incredibly vulnerable patients are sometimes just feet away from demolition. It is an unbelievably delicate and dangerous balancing act. So let's get right into those dangers, because the biggest risks in healthcare construction, they're the ones you can't even see. Think about it. When a construction crew demolishes a wall, they're not just creating dust. They're releasing microscopic particles that can carry deadly, aerosolized spores like Aspergillus, a type of mold that's pretty common but can be lethal. These tiny particles can get into the ventilation system, travel through hidden spaces above the ceilings, and find their way to immunocompromised patients. We're talking people in oncology, transplant, or ICU units, where a simple fungal infection can be a death sentence.
So how in the world do you fight an invisible enemy like that? Well, you do it with an incredibly sophisticated defense system, designed to protect the most vulnerable patients from threats both seen and unseen.
It all starts with something called an ICRA, which stands for Infection Control Risk Assessment. And the most important word there is proactive. This isn't some checklist you fill out after something goes wrong. No, it's a formal plan developed with infection prevention experts to map out every single potential risk and design a solution for it before a single hammer is ever swung.
An ICRA plan basically has three main lines of defense. First, you build these totally sealed, airtight barriers to physically contain the entire work zone. Step 2, you create negative air pressure inside that containment, which means air only flows in, it can't flow out, preventing any dust from escaping. And finally, any air that is exhausted from the site has to pass through special HEPA filters, which capture 99.97% of all those dangerous little particles.
But here's the thing. Protecting patients goes way beyond just infection control. In certain parts of the hospital, the actual design of a room becomes a life-saving tool, one that's engineered to protect patients from themselves.
Take a behavioral health unit, for example. Here, the absolute #1 design priority is suicide prevention. That means every single object in the room has to be rethought. Door handles, faucets, shower heads, they're all anti-ligature, designed so that nothing can be tied to them. All the furniture is anchored down. Fixtures are tamper-proof. Even the sprinkler heads are recessed into the ceiling. The whole layout of the unit is designed to maximize sightlines for the staff, so observation is constant.
Okay, so we've talked about protecting patients from construction. But what about protecting everyone from a catastrophic failure of the building itself? Well, hospitals are basically designed to be fortresses.
Just think about the electrical system. In your house, right, a power outage is an inconvenience. It's annoying. In a hospital, it's a life-or-death event. A standard building might have a single connection to the power grid. A hospital is required to have a completely separate essential electrical system with multiple branches and multiple backups.
So how fast does that backup system have to kick in? 10 seconds. That's it. In the time it takes you to stumble around looking for a flashlight when the power goes out, a hospital's massive emergency generators have to start up, sync with each other, and take over the entire electrical load for the most critical equipment. It's an absolutely incredible feat of engineering.
And get this, not all emergency power is treated equally. The system is actually split into 3 different branches, all prioritized by how important they are. The life safety branch, that powers things like fire alarms and the exit lights. The critical branch is for patient monitors and life support machines. And the equipment branch runs essential machinery, like medical vacuum pumps and crucial ventilation systems. This obsession with making things fail-proof, it has a name: N+1 redundancy. It's pretty simple. N is the number of components you need to run the hospital, let's say 3 giant chillers to keep it cool. N+1 means you install 4. That way, if one fails, the system doesn't even blink. There's always at least one backup for every single critical system, ready to take over in an instant.
This same principle applies to fire safety too. I mean, think about it. Many patients simply can't use the stairs in an emergency. So if there's a fire, the goal isn't to evacuate the whole building. Instead, the building is divided into these fire-rated smoke compartments. This allows the staff to just move patients horizontally through a set of special doors to an adjacent, completely safe area on the very same floor.
So what all this adds up to is just a staggering level of technical complexity. A hospital isn't just a building. It's more like a perfectly synchronized symphony of dozens and dozens of specialized systems all working together.
For a wild example, take an MRI machine. To keep its powerful magnets cool, it uses liquid helium. But in an emergency, all that helium can rapidly boil off in something called a quench event. This expanding gas can displace all of the oxygen in the room in a matter of seconds, creating a deadly asphyxiation risk. And that's exactly why MRI rooms have to have these dedicated, high-speed quench vents that pipe all of that gas safely outside the building.
And that's just one system. You've also got medical gas lines piping oxygen directly to patient rooms, a fire alarm system that has to talk to the HVAC system to shut down specific dampers, and nurse call systems that have to stay powered on no matter what. These systems don't just exist next to each other. They have to communicate and interact flawlessly.
Making sure that whole symphony actually plays in tune is a process called commissioning. It's this super rigorous testing phase that goes way beyond just checking if a single pump works. It tests the interactions. What happens when the fire alarm goes off? Does the HVAC system respond correctly? Do the emergency doors unlock? Does the generator kick on? Commissioning is what ensures the answer is always, always yes.
Which brings us to a final and I think really crucial point about all this. A hospital is never really finished. It's much more like a living, breathing organism that is constantly evolving.
To help it evolve intelligently, project teams will conduct what's called a post-occupancy evaluation, or a POE. They actually go back, long after the project is done, and ask the real users, the nurses, the doctors, the maintenance staff, what worked and what didn't. All that feedback is then used to make the next renovation or the next new hospital wing even better.
And this really is the ultimate takeaway. The construction never actually stops. Because medical technology is always changing, standards of care are always improving, and the needs of the community are always growing. A hospital is a living building, a never-ending project dedicated to one simple, powerful mission: saving more lives.
This really leaves us with a fascinating thought for the future. The challenge isn't just about building these incredible structures that heal the people inside them. It's about building structures that can learn, adapt, and in a way, heal themselves, becoming even more effective partners in care as time goes on.